Hey, what's going on, guys? Let's do this problem right here. The question is asking an insulated rigid tank is divided into two equal parts initially by a partition. Initially, one part contains 5 kilograms of air at 800 kilopascal at 75 degrees Celsius, right? And the other part is evacuated. The partition is now removed and the air expands into the entire tank. Determine the size. So they're asking for the volume of the tank and final pressure in the tank. Okay, so let's see how we can calculate this one. First of all, initial volume. To calculate this one, do we have everything? If you use ideal gas law, for example, PV is equal to nRT, PV is equal to nRT, or PV is equal to mRT, both will work. PV is equal to mRT. If we use M, we have to use R for air. It will be usually given in the table or in your book, but if it doesn't given, then you have to find the mole. So to find the mole, you still need molar mass, right? So in both way, you have to get the information. So let's use this one. So here, do we have we are trying to find the volume. We have the initial pressure, so we have this one right here, and we have the mass that's provided. R, we can find it from the book, and T is provided, right? So let's plug all the values. So V1 is going to be equal to mRT divided by P1. So this is also T1. So let's see how we can calculate. So first of all, we have M that's provided 5 kilogram and R value for air. If you look in the book, you will get 0.287 kilojoule per kilogram Kelvin, right? The temperature is provided in degrees Celsius. We have to convert this one into Kelvin, right? When we use ideal gas law, we always convert that whatever temperature into Kelvin. So here to convert this one into Kelvin, we just have to add 273 to it. So this is going to be 273 plus 75. That's going to be equal to 348. So this is 348 Kelvin divided by the pressure, that is 800 kilopascal. So 800 kilopascal. So let's keep it as kilopascal, because if you notice, this kilogram cancels. So let's show that one. So here this kilogram cancels, and Kelvin cancels. This kilo in front of joule, this cancels, and this kilo also cancels. So we don't have to multiply this one by 1000, right? We can keep it like this and cancel that one. So that way we will get the final answer in meter cube. If you want to know how, joule is equal to Newton meter, Pascal is equal to Newton per meter square. So Newton cancels, this meter square go to the top, and that will become meter cube. So now let's do the calculation. If you plug it in the calculator, you will get 0.624 meter cube. So that's going to be the answer for this one. And they are saying this tank is divided into two equal parts. So divided into two equal parts, which means to find the total volume, I have to multiply this one by 2, because we found out this volume. This is equal to V1 is equal to 0.624. So this also going to be equal to V1, because V2 is equal to V1 divided equally. So to find the total, we just have to multiply. So V2 is equal to 2 times 0.624, and that's going to give us 1.248 meter cube, right? Also, this is going to be the final volume, because they are saying finally they are removing the partition and expands into the entire tank. So we are going to have final volume, this total volume. So this is going to be the final 1.248 meter cube. And they are asking to find the final pressure, right? So let's see how we can do this. Let's look at the PV is equal to nRT equation. Maybe before I do that, let's compare the delta U, Q and everything, right? Internal energy change. Do we have any internal energy change? We are not adding any energy to the system, or none of the energy is going out from the system, right? And also this is well insulated. There's no heat transfer, there's no external work or internal work out of the system, so there's no delta U, internal energy change. So this is equal to 0. Q, as I mentioned, insulated. So this is an adiabatic system. There's no heat exchange. The heat is not going out of the system. Heat is not coming into the system. So Q is also equal to 0. Q can be written as mCp delta T. Right? So mCp delta T is also 0. This is same as this. Then if I expand this one, mCp T2 minus T1 is equal to 0. And if I expand this one furthermore, mCp T2 minus mCp T1 is equal to 0. And if I bring this to the other side, so this is going to be mCp T2 is equal to mCp T1. So from this one we can derive T2 is equal to T1, right? So this is, the temperature is going to be same in the both of these. So this is T1 equal to this, T2 is equal to this 75, the T1 is equal to T2. So temperature doesn't, or instead of, yeah, so we can just write it like this, T1 is equal to T2. Now let's use ideal gas law and see whether we can cancel and find the pressure, right? Cancel something. So PV is equal to nRT. So let's take the initial condition, pressure 1, volume 1, T1, P2, V2, nR, T2, right? So here pressure 2, volume 2, nR, T2. So if you notice, this whole value is going to be same because the temperature is same, right? Temperature is same, N is same, R is same. So we can equate both of them. P1, V1 is equal to P2, V2, right? So from this one, we know that final volume is not equal to initial volume. I made a mistake, right? This is V2 is equal to 2 times V1, right? Because we identified right here, when we open, that's going to be, the whole thing is going to be the volume. So instead of writing only this part, we can bring it outside and write V2 is equal to 2V1. So instead of writing V2, I can write 2V1. V1, V1, V2, 2V1. So here V1, V1 cancels. Now we are trying to find P2. P2 is equal to P1 divided by 2, right? So P1 we already know that's 800 kilopascal. 800 kilopascal divided by 2, that's going to be equal to 400 kilopascal. And that's going to be the answer. So let's round the answers. So they are asking for the determine the size of the tank. So that's the total volume we found out right here. This one. And they are asking for the final pressure. So final pressure is equal to this value, 400 kilopascal. And that's how we do these kind of problems. I hope you guys find this video helpful. See you next time.